Then we need to check if the health is 0. When the health is 0, it means the player is dead. The screen should fade out. We should play a dead sound, maybe a small bit of music as well to go along with the sound. Maybe the camera should actually fall down, so a camera animation should no longer be able to control the game, and so on. So we need to continuously check if the player is dead yet or not. And the way we're going to do that is by using the health player variable, and we're going to compare that. So compare int, and we compare it with 0. So we're going to check, is it 0 yet or not? If it's 0, you're dead, otherwise you clearly are alive. I will connect that to continuous update over here. You can see this blue box over here is called continuous update. It's connected to a tick event, meaning it runs all the time. So it's going to continuously check whether or not the health is 0 yet. Like so. When it is 0, actually when it's more than 0, so when the health is higher than 0, it doesn't do anything. Because this should just control dead, and clearly you aren't dead, so don't do anything. However, when it's equal to or lower than, we want to make sure it only executes once. Because if the health would be 0, and since it's connected to event tick, it would be executing it all the time. And we don't want the game to continuously trigger the fact that we just died. So what I'm going to add is something called a do once. So do once means it will execute it only once. And then the respawn, sorry, this shouldn't be connected to reset, wrong one. Should be like that. The respawn later on will reset it. So you can only die once, and you can only respawn once, and then the death event is reset again. Then let's first do a sound, or actually let's take away the player controls first. If you were to look in the player controller, so blueprint game player controller, and actually just open up the HUD while you're at it as well, because we need both. In the player controller, these are the controls of the game. So this is what controls the game. You can clearly see here, for example, let's take forward somewhere, move right. This one controls the left, strafing left and strafing right. It also controls strafe left, because the axis value here represents either left or right at the same time. Either way, when you press left or right, this gets triggered. This line is activated, but you can see it then goes into a branch with a bool set allow input. So as long as this bool is true, it will allow you to add movement input. It will allow the player to move. But the moment this becomes false, the signal would just stop. So what we're going to do now is we're going to set this bool to false the moment we die. Therefore, you can no longer control the character. So in the player, what I will do is I need to get the player controller. Get player controller. I need to make sure the game understands it's my type of player controller. This one in particular, Solus player controller. So therefore, I will cast again. Cast to Solus player controller. Like so. And then I'm going to say allow input. I'm going to set allow input. And I'm going to set it off. You can see it's not ticked. The box is off, meaning I'm setting it to false. Therefore, you will never be able to control the game anymore. In the same way, I can also do the same thing on the HUD. So if you go to the HUD, you can see these things over here, remote custom events, called HUD fade in and HUD fade out. When you trigger that, it will play this timeline. That timeline is a simple 1 to 0 animation. And that thing makes a color. So basically we just make a color and we change the alpha value of a black color. 000, it's black. And when it fades in, or rather, yes, when it fades in, it will go from opaque black to 100% translucent black. Therefore the screen has faded in. And you can see here this draw rectangle that just fills the entire screen. You can see it's very big, 4000 pixels across, fills the entire screen with that black color. So anyhow, this controls the fading. So if you were to trigger these two, we can make the screen fade in and fade out when you die and respawn. So if I go back to the Solus player, in the same way as I've done this, I can also do get HUD. So the only problem is get HUD doesn't exist. So what we need to do instead, and I believe it was a player controller, so let me try if it was that one. Get player controller and then do get HUD on the player controller. So now we have the HUD. Then we need to make sure the HUD understands that it's the Solus HUD. So cast to Solus HUD. And then here we can do HUD fade out, or I can just type fade, HUD fade out, and that will make the HUD fade out. So now when your health reaches 0, you should no longer be able to control the character, and the screen will begin to fade out. Let's try that. I cannot control the game anymore, and you can see the screen is fading out. So I have now died. We probably also want to have a sound to it. So same thing as we've done over here. I'm just going to copy this. And I'm gonna go for something called dead pain. There's also a little bit of music here. Dead respawn queue, you can try that as well. Probably better suited for the respawn system actually. So I'm just gonna stick to dead pain. Let me quickly try that again. And that works. There's one other thing you can do, is you can add a camera animation. So first of all, there are actually camera animations built in. You can type camera animation, I believe, probably shows up even here. Play world camera shake, for example, and those kind of things, but they don't seem to work. I'm not sure why. I think it needs C++. In any case, I've never been able to get those to work. So what I did instead, and this is not ideal, there are some problems with doing what I've done here, but it does work, is in the player controller, I'm actually taking the control rotation, which is the rotation of the camera, and I'm animating the values of that using a timeline. So set control rotation on the control rotation, the rotation of the screen. So basically I'm taking control away from the mouse and I'm rotating the screen based on the timeline. So again, this is not ideal, but it does work. That's already set up over here. You can look at it if you want. But the point being, there is a custom event called camera dead, which triggers the whole thing. So in the player, I'm also going to call on camera dead to get a bit of an animation in the camera going. Again, I need the player controller. I actually already have it cast here. So what I can do is I can reuse the same cast. You don't always have to make a new one. In this case, it's safe to simply use the same one again. So I'm going to do camera dead. Like so, and I'll very quickly try that again. And you can see the camera is falling down and it's fading out. So that also works now. And we now have a basic dead system. Then similarly to that, we need to have a respawn system as well. What I'm gonna do in order to facilitate the respawn system is I'm gonna write a bool. And again, there are, like with many other things, there are lots of other ways of doing this, but I think a bool is easy and straightforward. So I'm gonna write a bool. I'm gonna make a new variable, so a new variable, and I'll call it player has died. Player has died, and it's a bool. And I will set it. So I drag it in, set, like so, and check, true. So player has died is now true. In the same way, I will then do, I will continuously check for that. So get over here with a branch, and I will connect that branch to continuous update as well. So it's going to continuously check both if the player is dead, if the health is 0, and if the player has died. So if it basically passed this stage. If it has passed this stage, then it will allow me to respawn. I could be doing this in a different way as well. I could actually be connecting it all the way to the end here right away. That would work fine as well. It doesn't really matter, it's just different approaches of doing the same thing. In any case, I decided to go this way, so I'm going to stick to this. So player has died. Then again, we only want to make sure that happens once. So if the player is dead, it should only execute this once. If true, do once only. But if true, if the player has died, then we should later on reset this one, and this one in turn should reset this. They should reset each other. I'll set that up in a while from now. First going to set up the basics again. So do once. And this means we have to get the player to come back to life. So what I will do, first of all, a small delay, because we don't want the player to come back to life right after dying. So there is a delay here of say 5 seconds, and after 5 seconds you can by the way also get a delay if you hold the D key on the keyboard and you click somewhere. After 5 seconds it is supposed to remove the camera effects. So we have these camera effects here because we don't want to be spawning with blood on our screen. Then we haven't respawned. So we're going to destroy this one and this one. And we're going to reset the health to 1000. And later on we're also going to teleport the player back to the checkpoint. So health player gets set back to 1000. So we reset the health again. And we destroy the blood particle, get, and the glass particle, and we do destroy component on both at the same time. And then we tell the HUD to fade back in. So HUD fade in. I'll actually just copy this. And after a certain delay, I'm not sure anymore how long it actually takes. Let's check. It takes 3 seconds to fade. So after 3 seconds, I give the controls back to the player. So I do the inverse of what I've done before, and I basically do this step again. Like so, allow input is now enabled again, and actually we should probably be adding a sound to it as well. So I'm gonna copy the sound, set sound and play. I'm going to add this fairly early on, actually, not at the end, because it should happen already when you've died, or rather after 5 seconds would do fine. So I'm going to add it in between here. Need a bit more space still. And I'm going to set the sound to the respawn sound. So I'll type respawn. And there is a sound called SO player sound dead respawn queue. And let's give that a go. So that works. The timing is not ideal. The music starts a bit late. You might want to actually get control of the player back before the fading is done. because the fade does take quite a long time. So I'm gonna set the fading to 1 second delay. So you can tweak the timing a bit more. I mean, you can probably reduce this to say 4 seconds or add a second delay somewhere here. Either way, as it is, it works. Also, the problem was if I walk back into the trigger, then the sound gets overridden by the damage sound, because they both play on the same target. So you might want to consider actually playing one of the two on, for example, the footstep sounds, or you could add another sound audio component to it, etc. Either way, avoid playing too many things on the same audio component, so they don't override each other. We haven't handled the resets yet though, so at the moment you can only die once. So we need to handle the resetting of this one. And the way I'm going to do that is I'm going to connect all the way this at the end to reset over here. It's not super clean, you do get quite a long line. So if you don't want to have long lines like this, what you can also do is you can add a custom event simply to reset it. And that might be a bit cleaner, so I'll do that for the other one instead. So custom event. And I really can't type. Add a custom event, and I'll call it reset that do once. Connect there, and then I can call on that from the end of this one. So one arm resets the other arm, that's basically it. Like so. And again, I could have done the same thing here, it's just that the line is a bit more obvious what it does. What the point is. This arm resets this arm resets this one. Then we still need to have a checkpoint system, which we still don't have. And the way I'm going to handle that is I'm going to store the checkpoint in the player. So the player is going to remember the last location that was a checkpoint or a safe area. So I'm going to add a transform, new variable, and it's going to be a transform. So player checkpoint location is what I call it, and I set it to type transform. That falls off the resolution a bit, so let me move it up. Transform, it's an orange one. And a transform is basically 3 vectors. It's location, rotation, and scale. All 3 in one. So scale is obviously going to be 1, but this will therefore allow me to save both the rotation of the player, the right angle the player was looking at the moment it's saved, and the location in one single variable. And also, by the way, if you make custom events, sometimes you get this warning thing on it, but it just seems to be an engine bug, because if you were to recompile this, it would show up fine again. So sometimes suddenly a warning appears, but it's not really a warning in reality. So just disregard those. Either way, then we need to set the checkpoint. So on respawn, and we should do this before the screen fades in, otherwise you're going to see the player being teleported. So I'm going to do it over here before the fading occurs. I will get the player pawn. So get player pawn, and I will do set transform, set actor transform. I'm gonna see if this works. I might have to actually teleport it, because the player might not like have its transform set, but we can try. I can actually try already, because the transform has a default value of 0, 0, 0. So we can see if the player gets correctly teleported to 0, 0, 0, wherever that is, but at least it should go somewhere. Let's just see if the player goes somewhere. And that works, because I don't know where I am. I think I'm under the ground here. So the player correctly got moved back to the checkpoint. Next thing to do then would be to make sure the player has a checkpoint system as a way of actually writing its location to this one when he touches the checkpoint trigger. So on the other side of the room, I'm going to duplicate this trigger here, and I'm going to make a second trigger on this bar on the right side of the room. If you walk through this, you trigger the checkpoint. So this is a checkpoint trigger, this is a death trigger. Again, I'm going to use the level blueprint here. If you're going to be building an entire game where you have a lot of checkpoints, it's probably a better idea not to use the level blueprint, but to make a separate blueprint object, so a blueprint in here, that's called a checkpoint trigger, that does all that stuff by itself. So you simply have to click it, drag it into the level, and if you walk through it, it will do what it should do. However, to keep things simpler, I'm just going to be using the level blueprint. So in the level blueprint, when you touch that trigger, on begin overlap, again on the player pawn, cast the Solus player, it will set the checkpoint, set player checkpoint location, and it will set it with the location of the player pawn. So get player pawn again, and it will do get actor transform. So basically, when you walk through the trigger, it will take it will get the transform, therefore the location and the rotation of the player, and it will store it in this variable, so it remembers it somewhere. And then later on, when it needs it again, it will read this, which will then basically contain the last known location and rotation of the player when he was at the checkpoint, and move the player back to that point. See if that works. I should first trigger the checkpoint, so I've triggered the checkpoint. There's no indication of that, but the variable should be set. We can look in debug if it has been. And you can see if I look over it, it has the right rotation and right location. So that works. So then let's kill ourselves. And you can see I correctly respawn on the left side of the room. The particle, however, is still in view, so that might be something I have to look into. But I've correctly respawned at the checkpoint. Okay, so I investigated the fact that the particles remain on screen, and I found out that the reason is the following. What we do here when we spawn them is we define them in a variable. We do it here, and we do that here as well. But each time you take damage, and you take damage 3 times, because we set the damage over here to 400, each time you take damage, it spawns this one, and it spawns that one. Therefore, you have to take damage 3 times. Therefore, you will end up with 6 particle components. It will do this 3 times in a row. However, this variable only contains the last spawned one. So it only contains the last 2, one here and one there, but it doesn't contain the first 4. So when this thing over here runs destroy on it, it only destroys the last 2 and the first 4 are still there. So what we need to do is we need to be able to remember all 6 of them, all the ones that have ever been spawned and are still active. So to do that, I found out that you can do the following, because all of these are attached to the camera. So the camera here is the one that holds all of them. So what you could do is you could take the camera, and I'll move it down to where destroy is. I'm actually going to add a sequence here. So I'll add a sequence holding the S key on the keyboard, splitting up the signal. I'm going to bypass destroy because we're going to take out destroy and do it more complicated. So I'll just remove that actually. And let's actually make it give it a bit more space. There we go. So we have the first person camera, and what we can then do is we can ask for a list of all the components that are attached to the camera, so all the child components. So if you look for get children components, and that gives you an array. See that this if it's a squared dotted line like this, it's an array. The color identifies what it is, but a squared dotted line is an array. And an array is basically a list of stuff, so a list of variables. So now this is an actor array, so a list of actors. But if, for example, you would have a float array, this following would be a float array. So it's just a list of numbers. So every one of these is a float, but all combined becomes an array of floats, a float array. So this is simply a group of actors in a list. So this is everything that's attached to the camera. However, there is more attached to the camera than just the blood and the glass. Because for example, if you look here in the components, we can see the hand animation is attached to it as well. And in game, it might spawn some extra render things on top as well. So we can't just delete everything that's attached to the camera. We need to delete just those things that has spawned. So what I will do then is I will take the array and I will do a for each loop. So for each loop. And what that does is it executes a certain command or a certain function for each entry in the list. So for each actor that's in the list, it will do something. And then I'm going to say I need to figure out for each item in the list if it's a particle or not. So I'm going to say this is one individual actor that's found in the list here. So for this actor, I want to find out what the class is, what kind of thing it is. So get class. So now I know what kind of object it is. This is going to output it's a particle component, or it's a static mesh component, or it's a light component. And then I want to compare this. I'm going to do equal or parent class. Actually, let's see what it was. Child is class is child of. So I'm going to check if that's actually a child of the one I want to look for. I'm going to look for a particle component, or particle system component rather. Particle system component, because that's what we are spawning. We're spawning up here. You can see this is a particle system component. You can see it also when you hover over it, it says object particle system component. So I want to find all the ones that are attached that are particle system components. And then I will add a branch, because this outputs a bool, and I connect that there. So now I know if it's true, it's a particle, or it's something else. I'm going to connect the sequence here to the for each loop, because it has to start going through this. And then the loop body goes to the branch. I can delete that one actually. And then what we will do is we will destroy it. So we will take this one and we destroy it, destroy component. So if true, get rid of it. Is false, don't do anything. Now this should work. This looks like it should be working. However, I can't seem to get this to work without doing something else on top of it. So I'm wondering if this is an engine bug or if I'm really missing something here. Because clearly this should work, but what I think the engine does is when it destroys a component, the index in the array becomes empty, and when he goes through the array again, he gets stuck on the empty slot. He can't get past the empty slot, therefore he will no longer execute whatever comes after this one in the list of actors, and then it gets stuck and nothing happens anymore. That seems to be what's happening to me. So in order to work around that, I ended up doing this, which works fine, but it's not as clean as it should be. If you connect the destroy component back to the execute again, it will loop around. So basically what this does is that every time it destroys a component, it will refresh the list, because when it goes back into execution, it will get it again. It will do these two again as well. Therefore it refreshes the list. Therefore there are no more empty slots within the list, and therefore it will execute it correctly again the time after. So it's a little bit messy. Maybe they fix this in a future version. So if you're watching this in a couple of months or years from the date the video was made, perhaps it works as you would expect it to, like this. Anyhow, this appears to work, so I can quickly try that. And also actually before we try that, one small other thing that I didn't do earlier on. When we set the checkpoint system, like we do it here, you have to walk through this trigger to set the checkpoint location. However, the player might die before he ever reaches a checkpoint. So what we need to do is we also need to set a default checkpoint location. So what I'm simply going to do is I'm going to go to the player, and there's a section here called start game. This is a simple event begin place event. And what I want to do here is I want to do get the player pawn. So just get the player, get transform, get actor transform. So that's similar to what we do here. And then I want to set the player's checkpoint on default. So basically when you spawn, it sets the spawn location as the default checkpoint. So if you happen to die before you reach a checkpoint, you will just respawn where you started the game, as a precautionary measure. So I'll simply do that. Good, so let's try that. And you can see all the glass and all the blood is gone, so it works. Good, moving on from this, there are two major parts still to do before we can move on to the items. So the items will cover the entire second half of this tutorial. Before we can go there, two smaller things still though. First of all, we still need to get rain to appear on the player. That's very simple and very straightforward. It's just something small I would like to include as well. And then slightly more complicated is that we need falling damage. So now we've built this damaging system, works fine, we have a damage trigger, that's cool. But how about we put this into use and we make an actual falling damage system that relies on this as well. So what I want to do is I want to be able to jump off this beam here at the ceiling. And when I jump down, I should take damage from this fall. Okay, so how are we going to do this? The way I solved it for Solus is that I check at which point you start to be you're no longer walking. So I check at which location in the world the player is no longer in walking mode, but rather in falling mode. And then I check when the player lands. And then I calculate the height difference between the point where he started falling and the point where he hit the ground. And if that height difference is higher than a certain number, then I translate that in a certain amount of health and I deduct that health from the player. Therefore, we have falling damage. So step one is we need to figure out when the player actually starts to fall. And the way we can do that is if we just start somewhere in an empty space. And there is an event called event on movement mode changed. So the player has movement modes, and the movement modes they say what the player is doing. Is the player walking, falling, swimming, climbing, flying, those kind of things. So the way the player moves, that's a movement mode. So because of that, we now know what the previous one was and what the new one is. The new one is the one we're interested in. So we want to check every time the movement mode changes, I want to check, is the new movement mode then falling? Or rather, I should do equal to first. Equal, I think it's probably enum. Yes, that works. So equal enum, the last one. And then it says here none, so then you can select the different movement modes. So we want to compare to falling. Is the player falling? Then it outputs a bool, so I add a branch. Again, the B key on the keyboard. I do that. So now I know when the player begins to fall. Then I need to remember where he begins to fall from. So I believe I already have a variable here on the left. If not, you can always make it yourself. But there is a vector here that says player's location top of fall. That's a simple vector variable. So I'm going to set that. And I'm going to set it, if true, using the player's current location. So I can simply do get actor location actually, because that operates on self and this is the player, so therefore it takes the location of the player. So now I've stored where the player began falling from. Then underneath that, so actually this arm is already finished, very small one. The landed one is more complicated though. So this checks when you start falling, then we need to know when you actually land. Now I could use this thing again and just check if this is landing coming from, actually there is not even a landing one here, but you could go for walking coming from something else, from falling. But there's also something simply called landing, or land, event on landed. And this outputs when the player basically landed, after a fall, when he hits the ground. So we can use that to check when the player is falling down. You could always add a bool in between that says allow falling damage or not. That's what I did in the original game, so I can toggle it off if I want to debug the game. I'm going to skip that though. I do want to check if the player is not swimming, because he might have landed in water and then the fall would have been broken, or at least you would take less damage. So I am first going to check actually with a second branch, or a branch here as well, if the player is swimming or in water now or not. And the way I can do that is similar to this kind of setup. I can do get movement component, because it's the movement component within the player. Basically the character movement here, that is the movement component. That one handles the movement modes as well. So this one stores what movement mode you're in. Once I got the movement component, I can then ask, is swimming, for example. We can ask a lot of other things as well. You can see, you can ask actually, is falling, is flying, is moving on ground, those kind of things. You could actually use this system as well instead of, for example, that one, or instead of that one. I mean, you could do this different ways. And I can check. So if you're swimming, then if true, nothing happens. The signal stops. You will not take damage. If false, however, you must have landed on ground. So if false, then I can check if you have fallen further than the amount of the falling height you can take. So I mean, if you just fall 1 meter or a couple of feet, you probably don't take any damage, right? So we want to exclude the first couple of feet, first couple of meters, and only start having the damage apply when you fall from quite high. So I'm going to do a calculation to calculate just how high you're falling. Meaning I need to know again where the player is right now. So I do get actual location. This is basically where the player lands, because I'm going to execute this the moment you land. Therefore this becomes a location where you land, and this one that he stored, that was the location where you started from. So we're going to compare that one to that one. Okay, so we're only interested in the height really. So I'm going to break the vector into 3 floats. Break vector. Now I got only z, so it will only work with z. And similarly here below, I will do the same system with the player's location top of fall. Break that as well. And now I got the z from both. Then I want to make sure it's an absolute value, because otherwise my calculation goes wrong. So I don't want negative numbers. I want a negative number to be read as a positive number. Okay, so it's minus 4000 is what it outputs. Then I want minus 4000 to be read as 4000. It just removes the 0. And we can do that by adding an abs to it, absolute. Likewise for the other one, so I'll just copy that. Good, and then the next step is I'm going to subtract. So I'm going to subtract the location where you are now from the location where you began to fall. So the float minus float, it's this. Again, just for safety, it's probably not even needed, but I'll just add another abs to it just to really make sure I don't go under 0, because that would mess things up. And then I'm going to subtract again. So again, float minus float. And I'm going to subtract the amount of height that you can fall without taking damage. So let's just currently say it's 300 units. So you can fall 300 units without taking damage. So now once I have that, I want to check if you've fallen more than 300 units or not. So I'm going to do a compare on this. Compare float, which will then connect to this one over here. And I check with 0. So basically I want to know if you subtract 300 from it, the number it outputs might be a negative number, it might be 0. Either way, as long as it's negative or 0, it means you've fallen less than 300 units, therefore you will not take any damage. However, if it's more than 0, it means you've fallen more than 300 units and you will take damage. So to damage the player, we have this event we made earlier, which is called player take damage. It's a custom event. So I can call on that one from over here. So if higher than 0, it will do player take damage. Then we need to know the amount, and the amount should be scaled depend on how high you fall. So what therefore works, this is just a calculation as well, but this appears to work. I multiply it. So I multiply the last thing before it goes into the compare float, and I multiply it by 0.6. So I scale it down some, because otherwise it gets too much. So in other words, what I'm doing is if you were to fall 500 units, we subtract 300 units. Therefore, there's now 200 units left. Those 200 units would be scaled by 0.6. So I've got a calculator. that would be 200 times 0.6, so we now have 120, and 120 is the health we subtract from 1000, and is how much health you lose from falling 200 units. Okay, then the health is an int. You can see that's an int, this is a float. It will just convert it. It will do floor. Floor simply means it will take away the decimal point and keep what was before the decimal point. So in other words, 4 points, that would become simply 4.0. 2.9 would become 2. 1.1 would become 1, etc. This should work. Then there's one extra thing we can do to polish it up a bit. If you are falling but you aren't taking damage, so you're just jumping down basically, what we can do is we can animate the camera a little bit so you get a bit of an impact. So the camera kind of wobbles from the impact from the fall. So on these two here, what I'm going to do is I'm going to make a timeline, and I'm going to use that timeline to animate the first person camera. So I set it up like that, then we need a camera. So first person camera, and we will do set relative location on that. We'll use a lerp on this. So this is similar to how the door was made in the first video. So if you're new to this part, check out the first video to see why I do it like that and how it works exactly. Then let's say it only takes 1 second to play that animation. 0 and 0, 1, 1. It probably needs less than 1 second, I think, but we can try this first. That goes there, and then the numbers that work are Z71 for A and Z56 for B. And then we can try that out. So I'm going to start on top of the beam here near the ceiling, and I'll try jumping down. And that works because now I have 582 health. The damage effect popped up, and so on. Can try to fall down a little bit, not so high, and see if the camera animates. Which I guess is hard to see, but I do think it worked, but the fade-in was still active. However, it did seem a bit slow, so I'm gonna bring this down actually all the way to 0.25. And actually I'm gonna temporarily lower this number to or raise that number a lot more, and then just see. Actually I shouldn't have even done that, but I just want to test the jump impact. So I'm gonna start on a little bit of an elevation here, jump down, and hopefully that triggers the animation. I think it works, but it's still very subtle, so actually I shouldn't have changed that. That was fine as it is. I'm gonna make it all the way to 0.1. It works, but it's still extremely subtle, so let me just try to bump it up a lot more then. Actually, I am gonna lengthen it a little bit. So this needs some tweaking, but you can see it works. Even if you jump, because that also means you're falling and then landing. You get a shake when when you land back on the ground. Okay, then there's one last thing left to do, and that's the rain, before we move on to making the entire item system. So the rain is actually very straightforward. It's not going to take very long. in player character, or FX rather, we have a couple of FX here. For one, raindrops is more optional if you want to add it, but the most important one is in environment FX, sky, and then FX in that folder. And here you have local rain. So the local rain thing is literally a local rain cloud. This is probably very difficult to see on the video, but there are lots and lots of particles falling down. Actually, this works without light. The player is going to stand in the middle. It's basically a couple of cylinders with FX around, based around those. Player will stand in the middle, and the cloud will follow the player, because otherwise he would have to make the entire level covered in rain, and that would be very performance intensive and useless. So what we do instead is we have a local rain cloud that follows the player, and we simply toggle that one on and off depending on whether the player is indoors or outdoors and whether or not it rains. So all we really have to do, and again this is very fast, components, we'll add that as a component. So I have it selected in the content browser. I go back here, I add a component. You can see it shows up here as particle system component, system part local rain. There we go, you can already see it shows up. Actually, I can just play for a moment. This doesn't make sense obviously because I'm in a building, but it's more to build out a player and to show how you would approach certain things. Again, this is not the best level to show this in, but the rain works. The rain responds to light as well, which all is very difficult to see, but environment is too small, but it works. So the only thing we really have to do is add a custom event to toggle this on and off. And then we can make the sky. This is how I do it in Solus. The sky will then trigger that event in the player to toggle the rain on and off depending on what the sky is doing. So I will set the rain default off. So it says somewhere in here auto activate. I will set that off. And actually also when you deal with particles and translucent things, there is a property called translucency sort priority. You probably want to increase that to, let's say, 10. What number you put it on exactly doesn't really matter. The point is it's the sort priority literally. So you kind of have to make this up for yourself. For example, I'm going to say rain is 10. Blood particles on the screen should be 20 because the blood should be in front of the screen. So that should have a higher number. So you manually sort the depth of the scene basically. So I've added 10 to do this. And then to the blood and the broken glass I've done earlier, to be good, we should actually set translucency sort priority here to something higher than 10, so 20 say. Therefore forcing these to render on top of the rain and forcing the rain to render on top of whatever else there is in the level. Okay, I'm gonna rename this to rain particle. And then in here I can find rain particle. I'll do this somewhere in an empty space. I will make a custom event called rain active or activate rain, and another one deactivate rain. And that's that. Of course in Solus I have a little bit more, I attach the sound to it for example, so you also have a local rain sound that keeps following the player. And of course I also add in a check for several other things. For example, what we could actually add right now already is we have this indoor check here, which checks if you're indoor or not. So it does a whole bunch of traces, and if the trace hits nothing it means you're outdoors because the trace didn't hit anything surrounding you. But if it starts hitting something it means you're in a cave, you're underground, you're near a building, you are somewhere. And whenever it hits something it will set this bool indoor to true, otherwise false. So we can take that same bool and add it here as well. So the rain will only activate if you're outside. Like so. Of course, it's not waterproof. It's a very simple system. It's more to illustrate the point of how you would approach rain.